From a technical point of view, the Opel Insignia's adaptive 4x4 all-wheel drive is identical to the Saab 9.3 XWD all-wheel drive system. This active all-wheel drive system was developed in order to optimize the handling and stability of the vehicle in all driving conditions. It optimizes the distribution of torque between the front and rear wheels according to the conditions, resulting in improved control for the driver. It has a dedicated electronic control unit that works together with ECM, TCM, and the ABS and ESC control units. This gives the driver maximum road holding and strong, smooth acceleration, with imperceptible transfer of torque between the wheels. The chassis has been precision-tuned, and the all-wheel drive and ESC are integrated in such a way as to ensure optimum road holding and performance. The all-wheel drive system comprises 5 main components: the transfer case, the propeller shaft, the differential clutch, the limited slip differential, and fitted as standard from model year 2009.5, the limited slip differential clutch. The system also includes the all-wheel drive control unit and the hydraulics. The transfer case is attached to the transmission using bolts. It's an essential part of the all-wheel drive system. The transfer case makes it possible to drive the front wheels and the rear wheels together. The intermediate shaft to the right-hand front wheel passes through the transfer case. The gear wheel on the drive shaft drives the crown wheel shaft, while the bevel gears drive the propeller shaft. The propeller shaft transfers power from the transfer case to the differential clutch. The propeller shaft consists of 3 pipe sections: a front drive joint, 2 universal joints in the middle, and a rear drive joint. The propeller shaft support bearings are located at the universal joints. The bearings are mounted in rubber bushings, seated in brackets. These, in turn, are bolted to the vehicle underbody. The brackets are precisely positioned during manufacture. In order to prevent vibrations, the propeller shaft is not installed in a straight line between the transfer case and the differential clutch. The differential clutch is located in front of the limited slip differential and bolted onto it. The propeller shaft connects to the differential clutch at the front edge, while at the rear edge it connects via a splined shaft directly to the bevel gear of the limited slip differential. The all-wheel drive control unit is mounted on the housing. The main function of the differential clutch is to regulate the torque transfer to the rear wheels. A hydraulically actuated multi-plate clutch means that variations in drive between 0 and 100% are possible. Hydraulic pressure is built up with an electrically driven pump and regulated by the all-wheel drive control unit using a solenoid valve. The limited slip differential is bolted to the rear axle beam. From here, the drive shafts lead to the rear wheels. The limited slip differential consists of hypoid drive and a differential. The splined bevel gear shaft of the limited slip differential connects to the differential clutch. The bevel gear drives the crown wheel of the limited slip differential, which is fixed to the differential cage. The differential cage contains 2 planet wheels and 2 sun wheels. The limited slip differential clutch is attached to the left-hand side of the limited slip differential with 6 bolts. The function of the limited slip differential clutch is to fully or partially couple the left-hand drive shaft to the limited slip differential. This enables torque to be distributed between the rear wheels. The limited slip differential clutch is electro-hydraulically actuated by the all-wheel drive control unit using a pressure control valve mounted on the limited slip differential clutch housing. The purpose of the control unit is to regulate engagement of the differential clutch and, on vehicles where it's installed, of the limited slip differential clutch. The all-wheel drive control unit is connected to the vehicle P-bus. Bus signals coming from the all-wheel drive control unit are used to assess vehicle operation and handling, so that the appropriate torque can be transferred to the rear wheels. The control unit software can be updated by programming the PLC. The all-wheel drive control unit uses data from other systems. For example, the Engine Control Management (ECM) transmits the accelerator pedal position, the current and maximum torque, the engine speed, and pressing of the brake pedal. The yaw rate sensor, YRS, transmits the angular acceleration in yaw as well as lateral and longitudinal accelerations. The electronic stability program, ESC, transmits the wheel speed of all 4 wheels. And the column integration module, CIM, transmits the steering angle. The Automatic Transmission Control Module, TCM, transmits data about the selected gear. and the Body Control Module BCM checks whether the parking brake is on or Sport mode is enabled. The hydraulic pump draws oil from the tank and pumps the pressurized oil towards the oil filter. From the oil filter, the oil flows to the accumulator, which works by storing a volume of pressurized oil. The oil is then led to the pressure control valve for the differential clutch and to the pressure control valve for the limited slip differential clutch. From there, the oil flows to the clutch cylinder. The oil from the valve bleed port flows back into the oil tank. The Insignia's adaptive 4x4 all-wheel drive maximizes stability and driving in all situations. Depending on acceleration and driving style, the torque is distributed differently between the front and rear wheels. When accelerating in first gear on dry roads, most of the torque is transferred to the rear wheels. With increasing speed, torque is progressively transferred to the front axle. When the vehicle accelerates from rest with low front-wheel traction, almost all of the torque is transferred to the rear wheels, until the front wheels have enough traction to take over. Once the vehicle reaches a constant speed, the torque distribution is modified so that 5 to 10% is used for the rear wheels. Reducing the torque at the rear wheels reduces fuel consumption. At the same time, a certain level of rear-wheel drive improves directional stability. Under normal braking conditions, without activation of the ABS, the all-wheel drive system works as usual. As soon as the ABS engages, the differential clutch releases so that no braking torque can be transmitted between the front and rear wheels. The limited slip differential clutch was developed in rallying. It makes possible the distribution of torque between the two rear wheels. Based on data from the rear wheel speed sensors, the limited slip differential clutch transfers up to 40% of available torque between the drive shafts to the wheel with the best road holding. The result, improved traction and enhanced driving dynamics. When both front wheels and one rear wheel have low traction, on ice for example, the limited slip differential clutch transfers up to 85% of the torque to the rear wheel with the best traction. At constant speeds, torque is usually transmitted 90% to the front wheels and 10% to the rear wheels. When accelerating, distribution is modified so that 55% of the torque goes to the front and 45% to the rear wheels. This improves stability when overtaking. In certain cases, like pools of water on the road or forceful steering, the limited slip differential clutch can transfer up to 80% of rear axle torque to the rear wheel with the best traction. After finishing the overtaking maneuver, the torque distribution returns to 90% at the front and 10% at the rear. When cornering, the distribution of torque between the front and rear wheels is modified in order to prevent vehicle understeer. The limited slip differential clutch transfers the torque to the rear wheel with the best road holding. This results in enhanced safety. If one of the vehicle axles is raised during recovery, the speed must not exceed 50 km per hour. No technical limits apply if all the wheels are rolling. The ignition must be switched off when performing a two-wheel brake test.